Hello guys, Assalamualaikum and good day. So today we are going to continue our lesson on chapter 3, still on chapter 3, integration, and we are going to learn about the fourth technique, which is integration by partial fractions. So I hope you guys stay tuned with me until the end of this lecture. Okay? So previously we have learned three techniques of integration, which are first, integration by substitution, second, integration by parts, and third, integration by tabular method. Now for the final technique, the last technique, which is on integration by partial fractions. So before I proceed with the last technique, okay, you need to understand what is rational function and what is partial fractions. If you don't understand these two terms here, you may probably have difficulty to proceed with the integration process. Okay, so question, what is rational function? So you need to know that, okay, rational function, okay, is when the function is the fraction of two polynomials, okay, of two polynomials. So if mx and nx, okay, are two polynomials and they are in the form of fractions, so we call that function fx is rational function. Okay, so previously we have dealt integration by substitution, integration by tabular method, integration by integral by parts. We only deal with multiplication of two functions. But for partial fractions method, okay, we are dealing with the rational function, which is in the form of fraction. Okay, now such examples of rational function are like this, yeah. So we have x squared plus 4x plus 1 over x minus 1 times x plus 1 times x plus 3. This is 6x plus 7 over x plus 2 squared. This is negative 2x plus 4 over x squared plus 1 times x minus 1 squared. Okay, this one is 1 over x times x squared plus 1 squared. So basically all these are example of rational functions. Okay, so how about partial fractions? So what is partial fractions? So to get more details on what is partial fractions, you can go to the bonus chapter. Okay, by using the QR scanner, you can scan the QR code at the almost the last page of our module. You can get the details on how to do partial fractions. Anyway, I will give you a quick lesson on how to do partial fractions after this. Yeah, you can go to revision chapter here. Okay, revision chapter, the bonus chapter on algebra, and turn to page 22. So we're going to look into what is partial fraction. All right, so we know that previously we learned on what is rational function. So rational function is the fraction of two polynomials px and over qx. So from the rational function, okay, we actually can get the partial, we call this, okay, let me change the color. We can get the partial fraction decomposition. Okay, so before you can proceed the integration of the fraction here, all right, so just imagine that you are being asked to integrate the function of Rx, which is px over qx dx. So you cannot straight away integrate it like you used to do previously. So what you need to do is that you need to convert it into the partial fraction decomposition. Okay, so what is the partial fraction decomposition? In this case, okay, the partial fraction decomposition, okay, of the Rx, so Rx is Px over Qx, okay, you need to convert it into the form of like this. Alright, so how to do it, we're going to check it out, yeah. Alright, so for example, okay, you are being asked, okay, to integrate 6x over x squared minus 3x plus 2 dx. So how are you going to do this? The integration process is not like the previous one you have learned before. Okay, since this is rational function, okay, we call this rational function. Okay, and we have the numerator and denominator here. So the first thing that you need to do is that you need to convert it into partial fraction decomposition first as the first step before you can proceed with the integration process. Now, in terms of partial fraction decomposition, okay, there are actually 6 types altogether. Okay, the first type is, for example, okay, from this question, 6x over x squared minus 3x plus 2, you need to factorize it so that it will become x minus 1 times x minus 2. Okay, once you obtain this, then you can decompose it into its own partial fraction decomposition. Okay, so you can break it down into 2 components of partial fraction decomposition. Okay, the first component of the partial fraction decomposition is a over x minus 1, okay, plus b over x minus 2. Okay, now let's move to the second example or second type of partial fraction decomposition. In this example, I have 6x over x squared minus 1. Okay, so when you encounter this kind of question or rational function, you know that you have to convert or decompose it into ax plus b over x squared minus 1. Okay, now what is the difference between this type 2 and type 1 here? Okay, why in type 1 we don't have ax plus b and this bx plus c, and only in type 2 we have ax plus b? The reason is simple. It is because of the x here in the denominator has power of 2, okay, which is greater than 1. This one is x power of 1, okay, x power of 1. This one is x power of 2, x squared. So if you encounter the denominator has power of 2, have to convert or decompose it to become like this. Alright, ax plus b over x squared minus 1. Now we move to type 3. So in type 3, I have here 6x over x minus 2. Okay, and this function has the power of 2. Okay, it means that x minus 2 times x minus 2. Okay, now what you need to do is that since the x has only power of 1, okay, so what you can do is you can break it into two components, A plus B, and the denominator for A is x minus 2, okay, without power here, and then plus B over x minus 2 squared, okay. So just in case that if, for example, okay, the power here is changed to, okay, it's changed to 3, power of 3, means that you need to add up plus C x minus 2 power of 3. Okay, do you understand? I hope it is much clearer to you now. Okay, so with the increasing of power here, power of 4, it means that you have to add another one plus D over x minus 2 power of 4. Okay, now let's move to type 4. In type 4, we have the combination, okay, of which type? Okay, let's look at this example, yeah. 6x over x squared minus 1 times x minus 2 squared. So in this example, we have x with power greater than 1, x power of 2 or x squared, and we have another function that is power of 2. Okay, so basically this is a combination of type 2 and type 3 here, yeah. So what you can do is that you can break it into 3 components of partial fraction. So you can decompose into 3. The first one is ax plus b over x squared plus 1. So okay, this is not x plus 1, this is, let me correct that one, it should be, okay, it should be x minus 1, okay. And then next is the c plus c over x minus 2 plus d over x minus 2 squared. So c and d is actually representing the denominator here of x minus 2 power of 2. Is that clear? Now let's move to type 5. So for type 5, 6x over x times x squared plus 1 power of 2. So this is simple as well. So what you need to do is that you can break it down into here, since x squared plus 1 and then it is times up, oh sorry, it is power of 2, so it means that, you know, basically there will be x plus c over x squared plus 1, and then you have to do another one, dx plus e over x squared plus 1 squared. Okay, so you have to do it twice because of the denominator here has the power of 2 here, and then you have to at the numerator you have to apply x plus c and dx plus e because the power of x here in the bracket here has power of 2. Okay, is that clear? So basically this is a combination of this example, okay, x plus b here, okay, because of the power at x is greater than 1, okay, and then you have to do it another one because of this function, the whole function is power of 2. As for the x here, just straight away you can write down a over x, okay. And last is the sixth type 6, yeah, which is improper rational function. So basically what we have discussed previously from type 1 until type 5 is proper rational function. We call it proper rational function. So what is improper rational function? So improper rational function, it has divided into 2 categories. The first one, We call it as improper rational function because the numerator has higher degree than denominator. Okay, what does it mean? It means that if you look closely, the numerator here, the power of it start with x power of 3 or x cubed over or divide by x power of 2. Highest power at x start with 2, whereas at numerator the highest power start with 3. So it means that numerator, okay, 3 is greater than 2, right? So the power at numerator is higher than at denominator. So we call this function, okay, as improper rational function. Now, for the second category is when the numerator and denominator have the same degree. So in this example, x squared over x squared plus 3x plus 2, it has the same degree, which is 2. They share the same degree, 2 or 3, whatever it is, so long that it has the same degree, then we can call it as improper rational function. Okay, so when you encounter improper rational function for the type 6, remember that you cannot straight away decompose like the previous 5 types here, but instead, okay, must apply the long division. So how to apply the long division, we're going to cover it later on, but first let's check it out on how to find the constants a, b, c, d, e, and so on. So how to find these constants? Okay, once you can solve the constant a, b, c, d, e, and so on, only then you can proceed with the integration process. Alright, I hope that's clear. Alright, so basically you need to remember these 2 tips. The first tip is there are 6 types of partial fraction decomposition that you need to remember. Okay, and the second tip is it is important for you to look at the denominator, since the denominator will determine which type of PFD, partial fraction decomposition, that you need to choose. Alright, now, so once you obtain your partial fraction, you will notice that there are constants a, b, c, d, and etc. Right? So how to find that constants? Okay, so here I will explain to you on how to obtain it. So once you decompose it into partial fraction decomposition, that is the first step. Now we move into the second step, which is you need to multiply the denominator of the left side with each component of PFD at the right side. So here I have written it down for you. What do I mean by multiply the denom from the left side to the right side is you need to do like this. Okay, times up. Okay, here b x minus 2, you need to times up with x minus 1 times x minus 2. Okay, now what happened next is that, okay, you can cancel out the x minus 1 at a, and you can cancel out or eliminate x minus 2 at b. Okay, now the final answer will be 6x equals to a times x minus 2 plus b times x minus 1. Okay, what you need to do next is you need to expand it. Okay, so you multiply a with x minus 2, so that you will get ax minus 2a plus bx minus b. Okay, the next step is you need to rearrange it so that ax plus bx, you have the common factor, which is x. Okay, and then minus 2a minus b. Alright, so That will be your second step. Now we go to the next step, which is step 3. So in step 3, okay, we need to solve the A and B. There are two methods to find A and B. The first method is you need to equating the coefficients of the terms on each side of the equation. Okay, now what does it mean by equating the coefficients? It means that first, so we need to determine how many coefficients of x on the left side. Here we only has 6x. It means we only has x power of 1. So x power of 1 equals to 6. We need to equate on the right side. So right side we only have a plus b times x. So we just write down a plus b. Now we on the right side also we have minus 2a and minus b. However, on the left side there's no coefficient for x, so we just put 0. Okay, we just put 0 and equates with minus 2a minus b. The next step is you need to solve equation 1 and equation 2 by either using calculator. So you are allowed to use calculator to solve this simultaneous equation, or you can compute it traditionally. So I would like to teach you on how to compute it traditionally. So we have minus 2a minus b equals to 0. That is your first equation. And your second equation is a plus b equals to 6. Now, we want to eliminate b so that we can solve for a. So, what I do here is you can plus the equation 1 and equation 2 so that we can cancel out or remove or eliminate b. So, the next step will be, okay, minus 2a, okay, plus a equals to 0 plus 6. So from here you will get minus a equals to 6. So your final answer will be a equals to minus 6. So you already obtained your a. Now how about b? So that's very easy. So to get b or to find b, you just need to plug in a equals to minus 6 into either equation 1 or equation 2. It's up to you. Okay, in this example I pick equation 2, number 2, because it's easy, right? So b will be, since I pick equation 2, so b will be 6 minus a. Thus b will be 6 minus a is negative 6, so 6 plus 6 is 12. Okay, so are you done? Yes, you are done solving for a and b. So the last step is that you need to substitute or plug in back to the first step. Okay, so I write down it here for you. Okay. Alright, so this is the outcome that we obtain from the first step, from the partial fraction decomposition. What you only need to do is that you just copy the previous answer that we obtained, which is minus 6 into a and 12 into b. So this will be the final answer for the partial fraction decomposition by using the first method. Okay, we have learned previously on how to solve a and b using the first method. Now we move to the second method. Okay, in the second method, when you want to find a or you want to solve a, you need to choose the appropriate value of x so that the b will be eliminated. Okay, and if you want to solve for b or you want to find b, you need to choose the different value of x so that the a will be eliminated. Okay, now to understand on how to do this second method, for the second method, let's say if I pick x equals to 0, all right, what would happen to the equation above? 6x will become 0, and a plus b times 0 will become 0 as well, and minus 2a minus b. Okay, so when you rearrange it, okay, you cannot eliminate a or b, am I right? Okay, you will stuck with that, so it means that x equals to 0 is not the appropriate value, so we need to cancel it, cannot use it. So now we use x equals to 1. What will happen? Okay, so 6x, x substitute with 1, alright, and then a plus b times 1 minus 2a minus b. Okay, so you finish up the algebra. Here you need to have a strong algebra, okay, strong algebra skill. So a times 1 is a, b times 1 is b, minus 2a minus b, and then if you rearrange this, okay, if you rearrange this, you will find that b minus b plus a minus 2a. So b minus b, okay, you can cancel it out, alright, you will get 0. So what's left is that a minus 2a will become minus a. So your final result will be a equal to minus 6. Now, how about b? So we need to find a different value of x. Okay, so we try to use x equals to 2 in order to solve b. All right. Final answer is b equals to 12. So now you have you successfully find your a and b, and you need to plug in back to the partial fraction decomposition form. Okay. So you just copy it down, a over x minus 1 plus b over x minus 2. Then substitute the answer, same as the previous method. Okay. So this will be your final answer. So basically you should get the same answer like the first method. So if you ask me which method I prefer, method 1 or method 2, to be honest, my favorite method is method 1. But anyway, it's up to you which method you prefer to use. Okay, there's no restriction on that, yeah? It's just a matter of preference. Okay? Now let's proceed with the long division technique. So we will apply long division technique if the numerator has higher degree than denominator, or if the numerator has the same degree with denominator. So we have discussed these things previously. So now, for example, if I ask you to find 8 divided by 2, so you can use the common method like this in the fraction form. 8 divided by 2. 8 has the same factor of 2, which is 4. So your answer is 4. Alright. And then if I ask you to write it in the long division form, so this is what we call as long division technique. So 8 divided by 2. So 4 times 2 is 8. So 8 minus 8 is 0. So the final answer is 4. Now, if I ask you to find 17 divided by 3. Now, this is 17 divided by 3. So we can get the answer by multiply 5 times 3 is 15. So 17 minus 15 is 2. And I want you to write your answer in the fraction form. So the fraction form is like this. 5, right? 2 over 3 or divide by 3. So this is the final answer in the form of fraction. At the power at the numerator, it is a 3, and then the power at denominator is 2. So we know that we need to apply the long division here. Yeah, long division technique. So what you can do is that, right, here how we can do long division. So we know that here we want to cancel out 2. Okay, we want to cancel out 2x cubed, 2x power of 3. Here we have x squared or x power of 2. So it means that we need 2x. We need to times out with 2x. So here 2x. Alright. So do we need to put positive or negative here? Right? So we know that this is negative. We need to subtract it later on. Okay. Straight away 2x times x squared is 2x cubed. Right? This one you need to do it like this, yeah. So you times up here, and then you times up here, and then you times up here. Okay, is that clear? So let me proceed it with the answer. So 2 times 2 is plus 4x squared minus 24 times 2 is negative 48x. Alright, so what we will get is that this is 0. 3 minus 4, okay, 3 minus 4 is minus x squared minus 6x, okay, don't forget this one, plus 50. Now to cancel, to proceed, okay, just we need to have, okay, 1 here. 1 times x squared is x squared. So we know this is negative. So what sign should we put over here? What sign? Okay, is it positive or negative? Okay, if you put positive, you'll get positive here. What you will get is, right, minus x squared, you'll get 2x squared. So this is wrong answer. So what you can do is that, okay, let me erase this. You need to replace it with negative, okay? So negative 1 times x squared is negative x squared, and then the rest is negative 2x and then plus 24. So now this one is correct. Yeah, this one is correct, so we can proceed it. We can cancel out this one, negative positive, so this is 0. So again, you need to write down your final answer, okay, like this in the fraction form. It will become, right, equals to 2x minus 1 minus, okay, 4x, because I put minus here, so this will become minus 26 over x squared plus 2x minus 24. Alright, is that clear? So if you expand it, okay, negative 4x, negative will become positive 26. So this is how to do the long division. So now, to get the partial fraction, back to the question, to get the partial fraction, okay, we need to settle down this one, this part. So for this one, okay, you need to look at the denominator first. So from here, you need to choose the correct type of partial fraction component, right? So okay, is that clear? So let's continue. So let's deal with this 4x minus 26 over x squared plus 2x minus 24. You need to factorize this, so it will become 4x minus 26 over, okay, so 24 here, you want to get 2x, so 6 times 4, right? So since this is 2x is positive, alright, so plus 6 and minus 4. So here you need to have algebra skill in terms of factorization, okay? So from here, what we can do is that, okay, sorry, let me change the color first. Okay, so you can convert it into the partial fraction, which is a over x plus 6 and plus b over x minus 4. And to find a and b, you can now your task is to find a and b, right? So a and b, you can pick either two methods. Alright, either you need to equate the both coefficients on the left and right side, or you need to pick the second method, which is to find the appropriate value of x. Alright, so let's continue with partial fraction. So this one, okay, you can times up here and times up with b component. So what will you get is that 4x minus 26 equals to a over x plus 6 times x plus 6 x minus 4 times b x minus 4 times x plus 6 x minus 4. So this one we can cancel out because they have the same common factor. Okay, so this will be 4x minus 26 equals to a x minus 4 plus bx plus 6. So this will become ax plus bx minus 4a plus 6b. So 4x minus 26 is a plus bx. Then this one will be minus 4a minus 6b. So you can pick either method, right? Either method 1 or method 2, like we discussed previously, to solve for A and B. Okay? Right, so previously we have this question, okay? Alright, so 2x minus 1 minus 4x minus 26 over x squared plus 2x minus 24. Now we already convert it into, or decompose it into, right? So this is
4x minus 26 over x plus 6, x minus 4, okay?
and we already get what is the x plus 6 plus b over x minus 4. So the a value here is 5, okay, is 5, and the b is minus 1. We plug in the answers here into this. So what we will get is,
Okay, 2x minus 1 minus, so a is 5 over x plus 6, b is minus 1, so minus 1, x minus 4.
okay, so the final answer is negative 5x plus 6. Negative negative is positive 1 over x minus 4. So this is the final result, okay, of the question in example, okay, 1.12. I hope by now you are clear with this procedure or steps to get the partial fraction decomposition, okay? Some examples on how to solve integration by partial fraction, okay? Look into example 3.21, which is from page 86. Okay, evaluate x squared plus 4x plus 1 over x minus 1 times x plus 1 times x plus 3 dx. So in this example here, it is a proper rational function, okay, since the numerator has higher degree than the denominator. So in this case, in this example, you don't have to factorize it because it's already given in this factorization form. So let's have a look into the first step that you need to do. Okay, first of all, you need to decompose it into partial fraction components. So we will have 3 components here. With respect to the denominator here. So the first one is a over x minus 1, and then we have b over x plus 1, okay, and c we have x plus 3, c over x plus 3, okay. Right, now for the second step, okay, if you can remember, you need to multiply, alright, the denominator on the left side with each component of partial fraction on the right side. So here I have written down here, so a times with x minus 1, x plus 1, x plus 3. Okay, so we have the common factor, which is x minus 1. X minus 1, we can cancel it out. So what's left is a times x plus 1 times x plus 3. The same thing goes to component b and c here. So x plus 1 is the b has the common factor of x plus 1, so it can be cancelled out. So what's left is the b will times out with x minus 1 times x plus 3. Okay, same goes to c. So once you have multiplied it, you need to expand first the algebra here. Okay, so what you will have is that if you expand this, also this one and this one, you will get this. Okay, make sure you expand it correctly. So for example, x times x is x squared, and then we have x times 3 plus x times 1 is 4x, and then 1 times 3 is plus 3. Okay, so you do for all for the rest of it, for b and c. Okay, once you have expanded it, you need to rearrange them on the right side here, so that a plus b plus c times x squared, and then we have 4a plus 4ax plus 2bx. Okay, we have here. Alright, so I already factor out the x and x squared here, and finally we have plus 3a minus 3b minus c. Okay, so once you have rearranged the right side, so it's up to you to use method 1 or method 2, but as for me, my favorite method is method 1, which is equating the coefficients between the left side and the right side. So for example, on the right side, on the left side, we have x squared. So for the x squared, the coefficient for the x squared is 1. Alright, so we equating it with a plus b plus c, and then we have x power of 1, and the coefficient is 4, so I write down here 4, and the equivalent on the right side is 4a plus 2b. Okay, and then we have, when the x power of 0, the coefficient is 1. Okay, 1, so the equivalent on the right side is 3a minus 3b minus c. So each of these represent the first equation, the second equation, and the third equation. Now, if you want to make it quick, you can use the calculator to solve these simultaneous equations. So you will get from the calculator a equals to 3 over 4, b equals to 1 over 2, and c equals to minus 1 over 4. Now we move to the last step, step 4. We haven't discussed yet previously, because previous method we only discussed step 1 until step 3 on how to do to get the constants of a, b, and c. Now for the last step, which is to get the integration of the original question here, so what you need to do is that you plug in back, alright, each constants here into their respective partial fraction components. Okay, so here I have written down it. A is 3 over 4 times 1 over x minus 1 dx. So I have split up the integration here, because this is the sum. So we can do it one by one, yeah. So we can do it one by one, the integration process for each of these partial fraction components. Alright, so once you plug in each of the constants here, okay, now to make it easier, you take out the constants from the integrand. Alright, 3 over 4, 1 over 2, minus 1 over 4 from each of their respective integrands. To solve it, okay, now to solve it, since 1 over x minus 1, okay, it is much easier to use u substitution or integration by substitution. So here u, for this one, yeah, u equals to x minus 1, so du is equals to dx. We substitute back here, what we have now is 1 over u dx will become du. So 1 over u, if you integrate it, you will get ln u. So ln u, after that you plug in back the u equals to x minus 1 over here. So it becomes ln x minus 1. Same goes to the rest here. So your final answer will be 3 over 4 ln x minus 1. Okay, plus half ln x plus 1 minus 1 over 4 ln x plus 3 plus c. Okay, don't forget the plus c here. Alright, so now we will look into another example. Okay. Alright, so as for example 3.24, we start with the first step, which is to decompose the rational function into the partial fraction components. Okay, so here we have x squared, so that is why we have to decompose it into bx plus c. Now into step 2, okay, in step 2, you need to multiply the denominator at the left side with the components, partial fraction components on the right side. Right, so here we need to expand these two terms as well as these, so that you will get so we continue to expand the terms in the bracket with the term outside the bracket, yeah. So next step is you need to rearrange the coefficients on the right side. In this case, it means that you need to group all the coefficients that share the same power of x. For example, a x power of 4 and b x power of 4, you can group them up together by factorize the x power of 4, and this also happen to other terms as well. So we proceed with step 3. So in step 3, I use method 1, which is equating the coefficients. So here I managed to get a equals to 1, okay, and c equals to 0, as well as e equals to 0. Now to solve the remaining, we need to solve equation 1 and equation 3. You can use calculator. So if you use calculator, you will get b equals to minus 1 as well as d equals to minus 1. Now proceed with step 4. In step 4, we proceed with the integration process. So here, okay, you can plug in the value back into the partial fraction. So a is 1 over x, and then the b x plus c, since c is 0, and b we have minus 1 here, so we get minus x over x squared plus 1, and the rest d also is minus 1, so minus x over x squared plus 1 squared. So we can integrate the whole functions here. Next, we proceed with the U substitution to solve the integration process here. Here I pick U equals to x squared plus 1. So when you differentiate U, you will get 2x dx. Okay. Then, since we want to cancel out the x dx here, you have to ensure that the two constant bring it to the du, so it will become half du equals to x dx. Then you can proceed with the outcome, which is minus half ln u. Same goes to the another one here. So still using the same u, except that we have power 2 here, so we can use the power rule integration. So your final answer will be half u. Okay, and don't forget to write down your answers by substitute all the u with x term. Okay, it must contain x term and plus c as well. Okay, and there is a typo from your module. Change the negative to positive. Yeah. Alright, that's all from me. Alright guys, so stay tuned for my next video on integration of product of powers of sine and cos.